and read to read. Okay, read to understand. What would you like me to highlight? I think they're all still sleeping, Mrs. Hill. They're all length. Sorry? Sorry, what was that? I missed. That's important, the shape, clearly. And width. Hunter's going to take that earphone out of his ear. Anything else? Okay, where do you want to start? You want to like jump right in? Okay. X times. I'm just going to go there first. Where did the x come from? Okay, so our three dimensions are width, length, and height. Why are we multiplying them? Okay, since we have the volume, let's put it on the left-hand side. I agree. Okay, so get rid of the brackets, multiply it out. What would you like to multiply first? The x times x plus 8. Okay. Definitely still sleeping. Yep. Okay, multiply these two out. X squared times 3x. X cubed. X squared times negative 1. 8x times 3x. And 8x times negative 1. Okay. But I want it all onto one side. What kind of polynomial? Cubic. How do you solve a cubic? How many ways are there to solve a cubic? 2. What are the 2 ways? Factoring and graphically. Which way would you like to do it? Okay. How do we factor a cubic? Okay, pick something in for x and guess and check, and we're looking for this right-hand side to be 0. Now use some logic. 1, probably not a great number. Why? Because there's 2100 over here, so probably 1 isn't going to cancel. Plus, what are we trying to find here? And in terms of this situation, what does x represent? Yes, more specific. So in terms of this particular situation, the width, right? Was it the width or the length? It's the width. So probably 1 isn't a great value because it's probably not going to be that small if it's a width. Plus we have 2100 over here. So use the 2100 as a guide. So what are all the factors of 2100? Well, think of 21, right? So 3 is obviously going to be a factor. 30 is a factor. Why is 30 if 3 is? Because this ends in a 0. 300 is also going to be a factor because this ends in 2 zeros. Okay, what are some other factors? 7 and 70 and 700. What are some other factors? 100. What else? 50. So these are all great numbers to pick. Pick one. Pick one. 30. Good choice. Grab your calcs. What's the value? 900,000. 99,000. Can somebody confirm? What does that tell us about 30? It's not a factor, but it also tells us something else. It's too high. It's got to be too high because look at the value here. Okay, so pick another factor. Now you can either type all that in or you can recall it and just delete the zeros from the 30. Okay, completely up to you. Oh, that's 2. Using them up in the first 10 minutes. Okay, what's the value? 70? 7, just 7. Confirm the 7. Okay, what does it tell us about 3? It's not a factor, but it tells us something else. Too low. Question mark? Audience participation, welcome. It's closer, right? Closer than the 30 is because the number is smaller. Okay, pick something else. Again, you can recall it and just change all the 3's to 7, so save yourself some time. Happy with 7? That tells us that x equals 7, because when we put 7 in, we got 0. Now stop and pause for a second. Do we need to keep factoring? Are there going to be other values of 7 that are going to give us the same dimensions? Probably not. So once you're done here, once you found your 0, you're done. You can keep going and factor, but it's not going to get you anywhere because we already know the value of 7. So what that tells us is the width is 7. How do we find the length and the height? Length we said above was x plus 8. So the length has to be 15. The height, where does 22 come from? Correction of 20. Okay, our 3x minus 1. There it is. So the dimensions are? Bless you. Give me some units. Units, because it says right in the question, units. Okay, let's write a method. Step 1, what did we do? Right here. Write an equation. Step 2. Okay, what did we call that? So what theorem are we using when we're doing that guess and check? Yeah, so use remainder slash factor, doesn't matter, right? They're really the same thing. To solve for x. Step 3. Write the answers. Okay, so do we need to go on after we found the one that equals 0? So why did we stop there and we didn't do synthetic like we did when we were solving the questions? Because that's what x is equal to. So you're going to get other answers, but they're probably going to be decimals, or they're going to be negatives, or they're going to be fractions. So once you have what 1x is, you're done. Write the answers. I'm going to say don't forget units. Okay, let's look at number 2. So just read to read. Okay, looks very similar to the one above, so I'm assuming you probably want to highlight rectangular prism. Dimensions of x, 9 minus x, 11 minus x, centimeters. Maximum volume this time, so it's not asking the dimensions, it wants the volume. Perfect. Okay, so let's follow the steps that you guys wrote. Step number 1. Okay, length times width times height. Volume we don't know this time. Do we have the length? Yeah, do we know specifically if x is the length or width or height? We don't care. The second dimension? And the third? Now what? Okay, multiply it out. Offer of 9x minus x squared for the first one. Confirm. Okay. Okie dokie. Now what? But we don't have a number on this side. So the last one we had 2100 here. This one we've got two different variables. So other thoughts? What else can we do?
Solve for all three of the roots and then put them in to find out which one gives you the most volume.
But if we solve for the roots, what we're solving for is volume equal to 0. Because that's where it's going to cross the x-axis. So none of them will give us a max volume, because we know that's where they all equal 0. So good thought. Can we use those to maybe find something? What does a cubic look like? Draw it in the air for me. Okay, so what are we trying to find on that cubic? So we're not trying to find the x-intercepts. The highest point. So draw your cubic again in the air. And then show me wherever your max was. So we know a cubic has a max and it has a min, right? So wherever you drew your max. That's what we're trying to find, is what's that max value? So how can we find it? If we look at the end behavior, yes, but we still call it a max and a min, right? Because it's got one hump and one min. Well, you did this with quadratics last year. How did we solve for max mins of quadratics? Solve it how? Okay, so it is exam day. You are stuck. You have no idea how to do this question. What do? Well, you really pray that this is the first section of the exam, because what's the first section of the exam? So if you have no other method, what to do is grab your calculator then. This will be. Oh, my batteries are low. Even if you don't know what to do on the calculator, what can you at least do, if nothing else? Graph it. Even if you don't have a clue what you're looking for, graph it, get a picture. Okay, so let's go into x cubed minus 20x squared. Ooh, whoops. The arrow before the 3. The exponent key? Just over here under clear. Now what? Disk graph, okay. Okay, well that didn't give me a lot to look at. Sorry? Okay, go into window. Okay, what would you like me to change to? 36. Okay, graph. Okay, so what we'd like the min to be? Don't lose track of what are we trying to find. Go back to the question. What is this talking about? Dimensions. Do we need anything that's negative? No. So we know our min can be 0 because we can't have a negative dimension. Okay, max, we had an offer of 36. What would you like to do with min? For y, okay, it can be 0 again because we can't have a negative volume. As high as we want because the volume's obviously going to be bigger than the dimension, so give me a number. 500. Okay, and then we'll graph and take a look at what it looks like. Oh, isn't that cubic cute? The minute we have a graph, you want to go to your exam paper or your paper, and what do you want to do? You want to draw it, because that can get you marks even if you don't have a clue what you're doing. This at least tells your marker, hey, I did something on my calculator. I looked at it. So we've already talked, it's not the x-intercepts we want to find, because that's when the volume is 0. Clearly that's going to be the lowest volume. What point on this graph are we trying to find? The highest, which in this terms is that point right there. So you can mark a point even if you don't know how to find it. Well, we did this with quadratics. Okay, so let's see who can remember. How do we find a max or min on our calculator? Second calc. That's anything you want to calculate on a graph is always second calc. Maximum is a button. Okay, now what? Yep, go to the left just like x-intercepts. Offer of 3.28. And then we picked maximum. And then left bound, right bound. And that is 3.28. What did we just find? That's the x value. Okay, so in terms of our equation, what is that? It's the number here, but is that the number we want? Do we want the dimension of the maximum volume? No, we want the volume. Where is the volume on here? It's the y value. So the maximum volume is 144.8. Then I'm looking for the units. Centimeters cubed. There's your first maximum or minimum of a cubic. They'll always be calculator. There is an algebraic method, but you don't need to know it. Okay, so just write yourself some little steps. What did we do to find the max or min of a polynomial? Bless you. Okay, just make yourself some quick little calculator steps so you remember. Okay, number 3, read to read. So again, don't overthink it at the beginning. Just read like this is a paragraph in a book. Pretty boring math book. Okay, now read to understand. So what are the key words that we need here? Yep, in the math world, we don't care what it's a carton of. The word carton might be important if you're visual because that's telling you the shape. So because it's 3 dimensions and they use the word carton, it's just a rectangular prism, just like the other one. So it's just a box. Increase, good word there. Same amount. Increases by 350. Something else in that sentence. Something else in the sentence above that I would do, so the middle sentence. Capacity would be a key word. What's a synonym for capacity? Volume. So you might want to put that in brackets so when you look back you remember. Capacity is just the amount something can hold. Okay, typically it's used with liquids, but not always, as in this case. Okay, so just a couple different tricks that might help your brain to understand. One thing that sometimes is helpful is just to list the information off to the side. So for some people it helps to say, okay, the length is, we don't know, but it's one of the dimensions right now, so it's 13. Width is also one of the dimensions, and height is the other dimension. We're doing something to the volume. What are we doing to it? Increasing, so we're adding 350 to it. Okay, so some brains it helps just to list off to the side, number 1, because it makes sure you're processing all of it because you're writing it down. Number 2, left brains like lists. Visual people like pictures, so you can always draw a picture if you're a picture person. We don't know the exact shape of the carton. We don't care, quite frankly. We just care it's a box. And so 25, 13, 13, clearly a not to scale. And we somehow are going to make this thing bigger because we want to add 350 to it. How are we making it bigger? We're increasing each dimension by the same amount. That's what it says in the question. We're increasing each dimension by the same amount. Well, what's that amount we're increasing it by? We don't know. So if you want to start with defining a variable, sometimes that's helpful to get the equation. What do you want to call x? Well, it's the amount we are increasing each dimension. Okay, so just some hints to start word problems. Again, some people like to list, some people need a diagram, some people need to define a variable, all great tips. Okay, so if the length right now is 13 and we're adding x to it, what's the new expression for the length? 13 plus x. Okay, what's the new expression going to be for the width? Bless you. 13 plus x. What's the new expression going to be for the height? Well, if we're increasing the volume by 350, we need to know what the original volume was. How can we find the original volume? What was the original volume? So 13 times 13 times, kind of, 25, right, our 3 dimensions. Offer 225. Just looking to confirm. Okay, so our new volume has to be, can we say that like a mathematician? Okay, so what we need is our 13 plus x and our 13 plus x and our 25 plus x. And we need our 45, 75. Okay, let's make an equation. Okay, let's make an equation. Okay, there's the offer. Just take a look back at number 1. At this point, number 1 is exactly like this. The only difference with this one is they just increased at the beginning. So anytime you see a question now where they're increasing a dimension, it's always going to look like this. Why was it important they increased them all by the same amount? Why was that important for us? Because then we only have one variable. If they had increased them all by different amounts, we would have had 3 different variables. You don't know how to solve those. And that will come later like in your university career. So we can only do questions like this when they're increasing all 3 by the same amount. Okay, what do we do? Okay, now pause and think. Do we actually need to multiply this out in order to find an x that's going to give us 0? Do we need to multiply it out in order to sub in an x that's going to give us 0? Could we sub into this? We could. So it's completely up to you. If you want to multiply it out, go for it. But if you make a mistake in your multiplying, then you're never going to find the x that gives you the right answer. So you can actually leave it in this form, and we can sub a number into there. Okay, let's use our logic. If we had x as 0, we know the value would have been 4225. We're going to 4575. So is x a big number or a small number? It's probably a fairly small number because our volume's not increasing by that much. So let's pick a small number and see what happens. So pick an x equal to 3. Okay, let's sub that one in. So 4575 equals 13 plus 3 times 13 plus 3 times 25 plus 3. Okay, so that's 16 times 16 times 28. Sixteen times 28. A little bit louder, sorry. 68. Confirm. Now just note, because we chose not to multiply this out, which again you can if you want to, but because we didn't, we're not actually looking for 0 here now. What are we looking for? The 2 sides to be equal. So you might want to make a note, if you choose not to multiply it out, you're looking for the 2 sides to be equal. It's the same thing mathematically. Again, if you want to multiply it out, great. The problem is if you make a mistake in that multiplication, you're never going to find the correct x. So what does that tell us about x equal to 3? It's too big, right? It's got to be smaller than that because our volume here is too big. So let's pick another value. 1. Okay, let's try that. Ooh, equals. Okay, so 14 times 26. Sorry, say it again. What does that tell us? That it's less than 1. Okay, a lot less than 1, a little bit less than 1. Okay. .5. Okay, we got an offer bigger than a quarter. 0.5 is bigger than a quarter. Offer 46, 47. What does that tell us about 0.5? Okay.
I think that tells us we should give up and just graph.
You'd like to abort and graph it? Is that a valid solution? Sure. Okay, so how do you want to do this graphically? Okay, what are we plugging into the calculator? So where would you like to go back to? Okay, the very, very top. Okay. Here. This one? Okay, let's do it graphically. How do we graph this? We have done 4 kinds of equations now graphically. There are 2 methods. What are the 2 methods? Don't say method 1 and method 2. What are the 2 methods?
Method 2 and method 1.
Left-hand side and right-hand side. So that's intersect method, or bring it all over to one side and intercept. Which one would you like to do?
Intersect.
Intersect. Okay, so what would you like me to put into y1?
4,575.
Okay, and what would you like me to put into y2?
13 plus x times 13 plus x times 25 plus x.
And now?
We want to go to our window because it's probably going to be different than the last class.
Probably going to be different. You could do a zoom standard to get the idea at the beginning, completely up to you. Can we keep 0 as the x min? So always go back to the context. What are we trying to find? Dimensions, clearly not going to be negative. What do you think about an x max? Well, we already know roughly what the number's going to be, right? It's got to be between what? Yeah, it's somewhere between 0 and 0.5. So do I need to go up to 36? Probably not. So give me a better value. 1. Okay, what would you like the y min to be? 0. Okay, and what do you think about the y max? It needs to be at least what value? So go back to your equation.
4,500.
Needs to be at least what our volume is going to be.
5,000.
Oh, how cute is that? If you're going to go with a graphic solution, what do you need to show me? You need to show me the graph. What is the second thing you need to show me? Okay, how would you like to solve this?
Second function calculate 5.
Yes, second calc 5.
There is close enough to present it.
And what number are we looking for out of this? Is we looking for the x this time or the y? We're looking for the x. One decimal place, 2 decimal places, does the question say? So typically we give 2 if the question doesn't say. If you gave 1, that would be fine. Whew, are we done? Is that what the question asked us for? What did the question ask us for? The new dimensions. Okay, so how do we find length? Let's do that one first. Okay, so 13 point. The width. the height. Some units. Are we done? Have we answered the question? Okay, so you can do it algebraically, you can do it graphically. Typically with numbers like this, it's probably going to be a graphic question. Questions so far? So those are the ones we call dimension problems. You saw them last year with quadratics. The last example is what we call age problems. Again, read to read, and you're probably going to get bored halfway through. Oh, thank you. Hunter, you showed up in the problem. He's a baby. Anything else? Okay, so ones like this, if your brain works that way, it's always good to do that little information off to the side. So we'll list the people first, just so we don't forget anyone. So we have Leo, we have Sandra, Vince, baby Hunter. What do we know about Hunter's age? He's 1, so that's the easiest one because we know it exactly. Vince and Sandra depend on who? Leo. Do we know how old Leo is? So what do we put when we don't know something? Okay. Can we get an expression for Sandra if we know Leo is X? So how do we show 3 years younger? Can we get an expression for Vince who is 4 years older? Okay, now we have to deal with that product of their ages is greater than the sum. Okay, so let's look at a product first. How do we find the product of 4 things? Multiply. So we're going to have x times x minus 3 times x plus 4 times technically the 1, which we don't need it. Now I usually don't multiply out right away because again we might have that option, so I'm just going to leave it for now. I'm going to jump to the sum and we'll look at there and what's going on. How do we find the sum of 4 ages? Add them. So x plus x minus 3 plus x plus 4 plus 1. And it says the product of their ages is 54,658 greater than the sum. So all I did was translate that word for word. The product is 54,658 greater than the sum. Do I have an expression for the product? Okay, so let's put it in. And I'm going to leave the 1 out this time. Okay, 54,658 stays. And now I'm going to put the sum. And let's simplify this one up because we got a lot of x's hanging around. So how many x's in total do we have? And the constants, I've got -3, +4, +1, offer of +2. So just looking at this, would you like to solve it algebraically or would you like to do it graphically? Okay, so do we need to multiply out this side? No, so don't waste your time multiplying out if you don't need. We could simplify this side because it's easy enough. So let's do that. If I add my 54,658 plus 2, Intercept method or intersect method? Okay, what would you like to put into y1? And into y2? Okay, window values. Can we keep the x min as 0? Okay, how do we know 0 is a good number? Yeah, can't have negative ages. What about 1 for the max? No. Yeah, well, we know Hunter's 1, but probably the other ones are older, so give me a number. Okay, y min, 0, okay? Okay, and the max? So again, take a look at the biggest number that you have on this side. Has to be at least that. Offer 55,000. Remember, those aren't set in stone. If we look at the graph and we don't like it, we can always change it. I see not a lot going on. I see a little graph down here. There's a straight line at the top. Can we see where they're crossing? So what does that tell us? What do we need to fix in here? What do we need to see more of? The x max. Both might help. We'll see. Okay, so 20 was a little bit low. 60 is the offer. Do you want to change the y min, or y max, sorry?
I put it up to 60,000.
60,000 is the offer. Okay, let's see if that helped. Better? What do you need to draw? Yeah, so if you had the incorrect graph, but you had the point marked and you had the correct answer from your graph, that would be 2 out of 3. This question always makes me laugh because no adult would say they were 37 3/4. That kind of ends when you're about 5.
But at the same time, I'm pretty sure that no adult would actually.
Calculate the sum of the product of the ages? I might. Maybe it's a party trick that I know. Are we done the question? No. What did the question actually ask us for? How old is everyone? So how old is Leo? Let's start with him. What about Sandra? What about Vince? And baby Hunter? He's still 1. Some units. Age problems are always going to work that way. They're going to give you people in relation.